All right, welcome back to the drive-through. Hope everyone's having a wonderful day. Sponsored as always by the deli. Hungry? Stop by the deli. Make yourself a sandwich. That's it. That's all you get today. It's just a boring little day. We're in 5.2 here. This is our first section in Chapter 5, so we are skipping Section 5.1 on indirect proofs and getting right into proving that lines are parallel. But before we do that, we've got to introduce this random Theorem 30 that they just kind of throw in there at us. Okay? It says the measure of an exterior angle of a triangle is greater than the measure of either remote interior angles. Oh, geez. Okay, here's what this means. Take a triangle. Now, it's got no exterior angle right now. So, in order to make an exterior angle, take one of the sides and just extend it. Alright, so look. Here is our exterior angle. Now, you would have no idea about this, but these things are called the remote interior angles. Okay, this one and that one are the remote interior angles. We know that the exterior angle must be bigger than this angle and bigger than that angle. That's what Theorem 30 says. Does it have to be bigger than this angle? No, 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 no. That's not what it says at all. So let's look at a couple examples. Okay, if I drew like a weird obtuse triangle like this, okay. All right. So I know. Well, let's just think about this. Like if this was, let's say this looks like it's 20 degrees. Well, then this one must be 160 degrees. Okay, well, if you think about it, angle B plus angle A would have to be 20 degrees because the sum of the angles in a triangle equals 180. Well, that means that neither angle B nor angle A could be 0. So angle B and angle A must be less than 20 degrees. Oh, that's what the triangle, that's what Theorem 30 says. Okay, so we know that, you know, if I took away my numbers now, and if I just wanted to write a strict rule, I know in this question that angle AES is greater than angle A, and angle AES is greater than angle B. Okay? That's what Theorem 30 is telling us. All right, now we're going to just learn so many theorems in this chapter. So here we've got line L and line M cut by transversal N. Okay? Theorem 31 says that if alternate, so let's say 1, 2, 3, 4, 5, 6, 7, and 8. Let's say that we knew that angle 3 was congruent to angle 6. So if angle 3 is congruent to angle 6, then line L is parallel to line M. Okay? So this is how we prove lines to be parallel. So Theorem 31 says if alternate interior angles are congruent, then the lines are parallel. That's the shorthand version of writing it. That's what Theorem 31 says. You're going to use that in proofs to do what? You're going to use that in proofs to prove that lines are parallel. Okay? Theorem 32 would be, well, let's say we had angle 1 is congruent to angle 8. Well, then you could also prove that line L was parallel to line M. And that would be the alternate exterior angle theorem. So, if alternate exterior angles are congruent, then lines are parallel. That's Theorem 32. Okay? Theorem 33 would be like, let's say we had angle 4 is congruent to angle 8. Well, those are corresponding angles. So Theorem 33 says if corresponding angles are congruent, then the lines are parallel. So that is 3 ways to prove that lines are parallel. Let's go over 3 additional ways. There's going to be 7 theorems on today's assignment. 7. Okay, well let's look at angle 4 and angle 6. Angle 4 appears to me to be acute. Angle 6 does not appear to be acute. They appear to be obtuse. But what would be the relationship between angle 4 and angle 6 to make our green lines parallel? Well, I think they'd have to be supplementary to each other. Okay? So Theorem 4 says if same side, I think I need to write that out, same side interior angles are not congruent now, are supplementary, then lines are parallel. And how about 1 and 7 in Theorem 35? Well, that would be a similar theorem. If same side exterior angles are supplementary, then lines are parallel. Okay? There's 6 theorems that we've gone over for the day. Let's do another one. Here, we are given that line M is perpendicular to line L. And line N is perpendicular to line L. Well, you could see that those are corresponding angles, so line M must be parallel to line N, but we could also just say if 2 lines, if 2 coplanar lines are perpendicular to the same line, then those lines are parallel. We have a shortcut for this. So if 2 lines are perpendicular to the same line, then they are parallel to each other. Okay? That's the 7th equation of the day. So now let's just do one example before you guys turn me off. Find the restrictions on x. Well, we know from our Theorem 30, from our triangle exterior angle inequality, that 3x plus 20 must be bigger than 25. But we also know what also must be true is that 3x plus 20 has to be bigger than 100. Okay? So, here, 3x is bigger than 5. Okay? And x is bigger than 5/3. Okay? And in this one, you'd say 3x is bigger than 80. So x is bigger than 80/3. thirds. So we know that if x has to be bigger than 5 thirds and x has to be bigger than 80 thirds, then in this case, in order for that to happen, we just take the one that's more exclusive, so x has to be bigger than 80 thirds. Because if it's bigger than 80 thirds, then it's also bigger than 5 thirds. Boom!